Welcome students to this GCSE Geography lesson on the coast topic. In this lesson we will be exploring the principal coastal processes that operate to shape the coastline. Please write the date, title, learning objective. Let's go. Some practice questions to get you thinking. Write 1 to 10 and have a go at them, then self-mark. Okay, here are the answers. Mark your answers, please. Thank you. Let's go. So here's an interesting picture of a place that you might recognise. It's called Durdle Door. It's on the south coast of England. Using the questions, see how many of them you can answer already. Maybe jot them down. We'll see if you're right. This coastline, Durdle Door, is not a random formation. It is the result of a particular set of processes that are constantly happening at the coast and that have led to, for example, the beach and the arch seen here. Let me show you how they work. First, a keyword. Sediment, which is the rock of all sizes, from tiny grains of sand to large boulders, that is moved around in the sea or in rivers, can, under some circumstances, stop floating or moving and sink to the seabed, or just stop moving. This happens when the velocity of the water, that is the speed in a direction, decreases. When this process happens of sediment sinking or dropping, we call it deposition. Please write the word and the definition now. So, what processes shape the coast? The first is erosion, coastal erosion. It means the wearing away of the land by sea or wind and the removal of the material that has been worn away. For example, this material here that has been worn away from this cliff. From the previous lesson about mass movement, you'll know that rockfalls happen at this cliff because you have impermeable rock and horizontal and vertical strata and joints. Erosion is happening at the base, where the sea meets the land. Draw this simple diagram on a sheet or in your book to help you understand what's happening. The first erosional process is called hydraulic action. In every cliff there are small cracks and weaknesses. Waves get into those cracks, and what happens then is that the air inside the crack gets compressed, much like the air in a bicycle pump when you push down. And that air, when it increases in pressure, tries to escape, increasingly powerfully as the pressure increases. And when this air exerts pressure on the rock around it, it weakens the rock over time. Waves hammer into these cracks thousands and thousands of times, and eventually the compressing of the air breaks off the nearby rock, for example here, causing it to plummet down into the sea. This is called hydraulic action. And hydraulic action facilitates the second process of erosion, abrasion. Abrasion happens when loose pieces of sediment, large rocks or small pieces of sand, are smashed or rubbed against a cliff. And over time, this weakens the cliff, damaging it, breaking off yet more rock. That's abrasion. The third process of erosion is called solution. Some rocks are soluble, meaning can be dissolved, in seawater. Seawater contains carbonic acid as a result of the dissolving of carbon dioxide in the air. And carbonic acid can dissolve calcium carbonate, limestone and chalk, weakening it. Finally, we have attrition. Attrition is when pieces of sediment that are angular and large are smashed into each other by the sea and the waves and the swirling of swash and backwash, and over time they become smaller, smoother, and more rounded. So you go from a pebble beach to a sandy beach. All of these examples of erosion end up causing cliffs to retreat from persistently wearing them away. However, there are other processes that are critically important as well. The second one is transportation. Please draw this diagram. So transportation is the movement of sediment, both large and small, by the sea. The first type of transportation is called traction. This is when very large boulders are rolled along the seabed by high velocity water. A high energy sea is required to do this because boulders, being very heavy, require an enormous amount of force to move. Thus, traction only occurs when you have very stormy seas or waves that have a long fetch. Traction stops happening the moment the velocity decreases. Saltation, by contrast, is the bouncing along the seabed of small pebbles, seen here. Because the rocks are smaller, saltation can occur even when the sea has slowed down slightly. Thus, saltation occurs more often than traction. The third process of transportation is suspension. Sand can float in the sea because it's so light. And because the sediment is so light, suspension happens even when the sea is fairly calm and the velocity is quite low. However, even suspension stops in the calmest water and the sand sinks to the seabed. Finally, we have rock that is dissolved in water and it is invisible to the naked eye. It can only be seen if you boil the water off and the precipitate is left behind. This is solution, and it's always happening. Rock is always being moved by the water in its solute state. Thus, coastal transportation is the movement of sediment via these four examples around the seabed. It is responsible for the movement away from the coast of sediment that has been broken off, worn away by erosion. And it's why you find sediment in parts of a coastline that broke off from cliffs hundreds of miles away. Transportation. Finally, we have coastal deposition. This is when sediment sinks to the seabed because the velocity has decreased to such an extent that it can no longer be moved. And it happens under two conditions. Either when you have calm, sunny days or nights, and the water is at a low velocity, or it happens in certain other special conditions, such as this. When you have a cove like this, or a bay, water passes through the gap, and friction with the walls of the bay or the cove cause the wave to slow down where it's nearest the walls, here and here. However, the water coming through the centre here, far away from the walls, remains fast, and so the wave, instead of being straight anymore, starts to curve around like this as the water falls behind over here and here, but continues straight. Now you have a situation where the wave is spread out over a larger area. Same amount of energy, but spread out over a larger area. And so there's more friction operating on the same amount of energy, and the wave slows down. Thus, by the time the wave has reached the shoreline, it's very slow, it's a weak constructive wave, and it deposits sediment. Thus, in bays and in coves, you have deposition. This process in which waves spread out and curve when they pass through a gap like this is called wave refraction. And it is critically important for understanding why bays have beaches. Time to practice to ensure you've understood the main coastal processes. Answer these four questions and then self-mark. Let's go. Please mark your answers, add in green pen any parts that you missed. Thank you for joining me in this lesson.